Hello there. Welcome back to the Mark Chi School for kids who can't code good and want to learn to do other things good too. This is episode 2 of my Getting Started with Programming series, where I am teaching people how to use the Python programming language. And the project that we're kind of doing longer term is to do a kind of a Dungeons and Dragons simulator. It's not going to be like a full-on Dungeons and Dragons simulator, just a simplification of it, but we're going to get a lot of things coming through which should help us both understand how to code, but also have like a kind of cool project that we've done by the end of it. So in this second episode, we're going to start introducing some of the most fundamental programming concepts that are quite necessary to do a lot of the things we're going to need to do for this project and for coding in general. The first one of those is variables. How do we store information? How do we ask our computer to remember things for us that we can then kind of reuse information that we're going to see again later in our program? The other thing we're going to do is do our first steps in communicating with the user or the player, depending on how you want to look at it. The human that is using the computer is going to give some information to the computer, and we're going to get some information back. So our program, instead of just going kind of on rails, can react to what the player is doing. So let's go back to my coding scene here. If you've seen my episode 0, you'll remember that we're up to this point where we had a hello world that was printed out. I might just zoom this in a bit so you can see the code more easily. So we set up this message hello world, and then we used this print here. You can see when I hover over it, there's a lot of detail about it. We're not going to go into all of that yet. But the print is a function, is what these things are called. I will go into detail about functions later, and it's going to take this message that we have here and make it appear. So just as a recap, I will run my code by typing in Python and then the file name that I'm running, and it will print out hello world. So there's a few things going on here that I didn't explain last time, because I wasn't really talking about code concepts as such. I was just saying, all right, let's get our program set up so that later on we can learn about code. So this program's only got 2 lines of text, but there's actually a lot going on here that we want to learn about in order to understand how programming works. So I did mention previously that a computer program is kind of like a recipe. We write the recipe, the computer cooks said recipe. So what the computer is going to do is going to take our instructions line by line, and it's going to, like we would say, turn on the oven, preheat it to this amount. So we have to do that before we put things in the oven. So we want one task to be finished before the next one starts, that kind of thing. So at its basic level, programming is a series of instructions that the computer is going to execute. It's going to run those instructions one at a time, and we can think of that as each line of code being a separate instruction that is executed one after the other. It's actually more fine-grained than that. Each of these things is actually that you can put multiple instructions on one line. But if we think of it as line by line, that's a good way to start thinking about how our code's going to run. So the first thing that happens here is we set up a message. This was called MSG, which is literal shortening. Sometimes a lot of us programmers will do shorthand for our variable names, but I mean, you could quite easily give this a full word name and it would still be understood. So what this has actually done is set up what is known as a variable. So if I say a name of something, so it doesn't have to have existed before in the program. This is literally the first line of the program. I say, I want to make something, and it's called message. And then I'm going to put an equal sign here. You don't always have to put the equal sign here, but I put the equal sign here and say, this is what the message is. This is the most basic form we can have of creating a variable in Python. It works similarly in other languages as well. We won't go too deep into other languages. But what I have created is a name And when I create that name, I actually kind of say to my computer, can you remember something and associate it with this name? So I've said, I want you to remember this. And the equal sign is really funny in programming, because if you've done a lot of maths, your equal sign, you'll think of the equal sign as being both sides of this thing are the same, or equate to the same thing, evaluate to the same number. In programming, the equal sign's used quite differently, where after this instruction, this line of code is executed, yes, both these things will be the same, but what the equal sign's actually doing is it's taking the right-hand side, so whatever we put on the right hand of the equals sign, and it's putting it in the thing on the left. So we want the thing on the left to be a something that can store information, so a variable like this. We create the variable just by naming it. We don't really need to do anything else. We just say, this is a thing and I want to store information, but I'm giving it a name so that I can come back to it and use it again later. And this is the information that's stored in it. Then here, I need to name it correctly now that I've changed the name. This message in here is this same thing. I'm referring to it again. So if I go back to my cooking analogy, here I've said, I want you to chop up some vegetables. You know, I'm being very metaphorical here. And the vegetables I want you to chop up are these letters here, hello world. So once you've chopped up those vegetables, you don't throw them away. You put them in a bowl or something like that. You prepare them ready to be used again. And this print message could be called, I don't know, stir fry those vegetables. So I take those same vegetables and I know which vegetables I'm referring to because I use the same name. So that when I do this print function, which is something else that Python provides for us, it knows that if I referred to it as message, I was referring to this information, hello world, that was saved for me. So you get this nice situation where you can set up a series of information, like for this is a series of letters, or I can have number equals, I just made that up, 10, could be any number, you know, could be 7, could be 42. There's lots of, like, you know, really significant numbers to people for different reasons. And so now I have kind of prepared one ingredient called hello world, and I've prepared another ingredient called number. Sorry, the first ingredient was called message, and it was storing hello world. The second one's called number, and it's storing 42. And so we can use these things now to do different things. So I could print out the number as well. So if I just save and run this, I press Control S there to save it. That's as much of my keyboard as you're gonna see. I press Control S. That's what my fingers did. And if I run this again now, so one of the nice things about the terminal here is if I just press the up arrow key, it'll go back to the last thing I did, the last instruction I gave it, and allow me to run it again. Press enter there, and I get hello world 42. So that's nice. Now I can see that this function that can print things out is able to not just print out the letters and words, it's actually able to also turn a number into something that it can print out on the screen. So that's nice. We have asked our computer to store 2 different bits of information, and we're able to use this inbuilt Python print function to send that information here to our user so our user can see something is happening. And it's nice because we want to be able to see what's happening. The cool thing about this is I can use this number again. I can do other things with it. So a lot of basic maths that we can do with these variables. I mean, when I say basic maths, we're not really going to be able to do basic maths on hello world. It's not a number, so it doesn't do maths. But I could do something like number equals number, let's do +1. Let's do something really, really simple. I was going to do multiplication, but let's just do +1. What this does is it takes whatever's on the right-hand side and puts it in whatever's on the left-hand side. So this is kind of interesting, right? Because I have the variable here, number, and I'm using the variable here, number, as well. So it's like, ooh, which one of these things goes first? It is what's on the right-hand side usually goes first, and it puts it into what's on the left-hand side. So this number here is going to read the number 42. It's going to add 1 to it, and then it's going to store whatever the result of that is in this variable number here. So if I was to print out this number again, what I should see is I'll get my message, hello world. I'll get the number the first time, 42. Then I make some changes to the number. I've added 1 to it, and I print it out again. I should now get a different number. So what these print statements are kind of doing for the moment in what we're learning about is they're going to show us what is happening right here, right now, at this point in time, as I was partway through the cooking of the recipe. So when I was partway through the cooking of the recipe, I'd done something with the number, I'd created it, and then I print it out. After that, I can do something else with it and then print it out again. It should now be a different number. So every line of code not only is an instruction that the computer will execute one at a time, but if we look at when it executes things, it's kind of a snapshot of what the program sees and thinks at that point in time. We call that the state of the program, and the state of the program will be constantly changing as we do more things. So as we go through lines of code, the state of the program evolves based on whatever maths it's doing, whatever processing it's doing, whatever information we give it, which I'll talk about in a sec. So I run this again, and I get hello world 42, 43. So that's pretty cool. We can do maths with that. Let me also show you some things that we tend to do as programmers. One thing I like to say is that programming is 50% for the computer and 50% for humans. And I think that's quite funny because when you first start programming, you might think programming is 100% for the computer. Like the only reason we're writing this stuff is so that the computer can run it. But the trick is, with a lot of the code that we're writing, what we're really trying to do is make it so that we can understand what we were doing and we can use it again later. So in order to assist in understanding, I can write these things called comments. So this is a comment. I'm probably not going to leave a comment saying this is a comment. That's a little obvious. But the trick is, here in Python, this is specific to Python, other programming languages do it differently. I use this hash symbol, and my computer will ignore this line now. So my computer says, that is not code because you said this is a comment, it's a hash. Not because I typed this as a comment, just because of this, the hash symbol here tells my computer to ignore this line, which means I can now write stuff in a pure human language for a human to understand. So what I might write here is we can reassign the value of a variable. And I might write here, we can create variables by naming them. We can immediately give them a value by using equals. We call this assigning the value. Our code's not often going to have quite this much in comments in it, but I'm happy to put a lot of comments in this just because this is teaching, right? So I want to give you a lot more information than you would necessarily write in your code. So if I'm writing this code for the purpose of teaching people, lots of comments, lots of information. But when we're writing this code just for general use, we might not explain every tiny little thing that we do. But we would still be paying a fair amount of attention to the way we name things. So I named things quite carefully, obviously working in the English language for me because that's my speaking language. And I'd hope that anyone I'm working with also understood English because it's harder to communicate otherwise. But I will name my variables things that make sense for the variable. So anytime I create a variable, I usually give it a noun as its name. And I usually try to make it so it's not ambiguous, like you could tell it apart from all of the other variables that have been created for this program. So I've only created 2 so far, so that's not too bad. It's really easy to differentiate the 2 of them because one is a message with some text in it and the other's a number just with a number in it. The interesting thing though is like once we assign something to a variable, it then kind of gets selected and pigeonholed into using that type of thing. So with the number being 42, we're probably going to be using that from then on as a number value, and any changes we make to it are going to be number values, and anything we try to do to it is going to treat it like a number. So there's an interesting situation here. And the fact that I also didn't put any decimal points on this, so I didn't say 42.0, 42.5 or anything, makes this a integer variable. So integer, if you have not heard of the term, an integer variable is a whole number with no fractions or decimal points. So this is like if you're counting things and you're not counting halves of things. So you're saying, I don't know, back to the cooking thing. I have a bag of potatoes. And if I don't cut any of them in half, then I can count these as individual potatoes. And so this is like a whole number of potatoes. So until I cut them, there's no fractions of them. We're not worried if they're bigger or smaller than each other. They're just whole numbers. And that's what an integer is. In programming, we would often shorten this to the phrase int. And I'm telling you about this because what I'm going to do in a second is combine my print statement with both some text and a number. So you know what I'm going to do? I'm just going to remove this one. And I'm going to put some text in here, and I'm going to say, after changing it, number is now something. And it's kind of cool because we can use plus to attach things to each other. So I shall do something simple. Do something simple first. Let me write out. Oh yeah, I'm gonna do it this way. Our message is, and I do a plus, and I put message in there. So the cool thing about this plus here, this isn't the mathematical plus that I used here. The plus symbol is actually able to change what it does based on the context of what it sees around it. So if it sees numbers, it says, oh, I'm just going to add these numbers up. If it sees strings, that's what these are called. Hang on. String variable. So I'm going to put as much information as I can in here, so you can look back over this if you want. String variable, this is a sequence of letters. I'm going to say letters or characters. Technical term that we're going to use once we get deeper into things is these are characters. So if I see numbers, I know I can do maths with them with the plus. And if I see strings of letters, the plus is actually going to join these together. So I'm going to save this and run this, and you'll see how this works. So hello world 42. Oh, I didn't actually print out the number again because I deleted that. That's fine. Our message is hello world. So you can see what it's done is it's taken a string here and another string, and it's connected them together with the plus. Interesting thing now is you might be asking, what happens if we do a plus and we can't be sure which one of those things it's supposed to do? Number has been changed. It is now, and I'll do a plus and then number. So now what I'm saying is I've got a string and I've got a number, and I want to add those two things together. On the one hand, we could try to attach a string to another string, but this one's not a string. It's an integer because when we created it, we gave it an integer value. Or I can say we're supposed to be doing maths. Add this number up to this thing. This thing's not a number. So these things can't necessarily work together. And the plus is now confused because it said, I could have done this or this, but now I don't know which one. let's run this and see what happens. So a lot of the time when we're doing programming, we're going to learn about how we figure out what our code is doing, and how do we figure out what changes we need to make in order for it to do what we intend for it to do. So I'm going to run this and I'll just expand this out so you can see more of it. Okay. Here is where we made the last call to run the program. And so our hello world worked, 42 worked, our message is hello world. So we got as far as this thing and this ran, and then we got to this line and it attempted to run and then something went wrong. Traceback, most recent call last. So what this will tell us is where the program was up to when it stopped. And this is a lot of what we're going to learn about. It's learn about error checking and stuff like that. And so it said, this is the last thing I tried to do. Number has been changed. It is now plus number. So I was trying to say it is now 43, but it says error can only concatenate string, not int to string. So this is the shorthand. Concatenate, if you have never heard of that word, concatenate means to join two sentences together, in a sense. It actually doesn't necessarily mean sentences. It could just be words, but it means strings of characters attached to each other. Not even specifically characters. I'm pretty sure you can concatenate lists of numbers and stuff like that as well. And it's different from adding things together. It's kind of joining things together in an ordered sequence. So the first thing goes first, the second thing goes after it. And it's saying I only do this thing with strings, not integers. So I cannot do this with an integer. So we get in this situation where it's like, okay, how do we make this specific and say, how do we output this thing as a string? Because I want to join these things together one after the other. I do want to concatenate. So what I'm going to need to do then is convert this number into a string so that my concatenate is really, really clear on what's going on. My plus symbol is really clear on what's going on. I am not confusing it by saying there's a number on one side and a string on the other, but both of these things are strings. And I do this by a method that's known as casting. Casting is like temporarily saying to a variable that it is not the type that it originally was. So I said here, number is an integer variable, but what I can say is, pretty sure you can come up with a string version of yourself. This is only working because the variables in Python are set up in such a way that they can actually appear as other variables. So when the string is a number, it has a value, which is 42. So that's a numerical value. It's able to be multiplied, divided, added to, subtracted, and stuff like that. But when I say use it as a string, it becomes the letter 4 and then the letter 2. So as opposed to these having numerical values, they basically are characters that can be displayed on a screen. So when I say make this thing into a string, and I save this and run this, I might get a different response. Okay, so hello world, 42 was our first. So we print the message, and that would be the message hello world there. Print number 42 there. Our message is hello world. The number has been changed because previously the number was changed. It is now 43. So this thing allows me to say the number is a different thing from something else. That's a start on how we're going to be using variables. There's a lot of maths that we can do with variables as well. So I'm going to put another note in here. Basic maths. Should call that arithmetic if I want to be really technically correct. Basic arithmetic here. Okay, I'll type it. Plus, minus, divide, multiply. So you note that these symbols here, if you've done maths in school, are not exactly the same symbols that we would get if we were writing this down as a mathematical equation. The trick is that some of those things don't exist on a keyboard. And if we use the X for multiply, then we'd have a character instead of a symbol in amongst what we're doing, and that could confuse things. So the slash for the divide, so divide is like a fraction, right? So one thing over another, so we can use the slash symbol to divide The multiplication symbol is a star, an asterisk, instead of an X, but it'll do the same kinds of things that you expect. If you put a number with the arithmetic symbol and another number, they will evaluate the same way that basic maths would evaluate them. So some of the little things that we can do, we can reassign variable values like so, and we can also process variables to do things with them. So that's the basics of variables. And remember how I said that there's two fundamental parts to the computer? Like, I was really simplifying it. One is the thing that processes stuff, and the other is the thing that remembers stuff. Storing variables is the remembering side of things, and doing arithmetic like this is the processing side of things. And we could consider this printing out messages to kind of be the processing side of things as well. So the printing out stuff is not changing what we remember or what we know, it's just doing something with it. Print's a little more complicated because, as you can see, there's a lot of information here. This is, like many other things in Python, is something that's part of the language itself, something that another human somewhere in the world has written that allows us to use parts of our computer without us having to learn how to do it. So we don't have to learn how to take these letters and print them out on the screen here. We allow the programming language, in a sense, to deal with it itself. So another thing that we can do, which is interesting, is to actually take information from our user or our player and put it into the program. So I'm going to create another variable, and I'm going to call it input. Now, I don't have any information in this input yet, so I'm going to show you another thing that I can do when I'm declaring a variable. This is a list variable, which is something that can contain multiple objects. And a string is a type of a list, in a sense. So it's a list of characters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I was counting and then I lost count. I think there's 12 there. This is 12 separate characters in a list. But what I can do is I can say there's nothing in this list. So I could create a variable that's empty like this. Then what I can say is I can ask our user to type something in. Actually, you know what I'm gonna say? I'm gonna name this something different because I'm about to use the same word. There is another function that Python provides us called input. And input says, I am going to take information that is actually typed in here when the program's running. So we start to think of this as two different time frames, in a sense. There's when I'm writing my code, I'm in this kind of before you start cooking time frame. I'm creating the recipe. When I run Python here, the computer will execute all my instructions one after the other. So what happens here with input is the user will then type in something here, the program will pause here and wait for them to do so. So I can say input string equals input. So note that if I want to have a space in my variable name, I can't actually have a space, because if I have a space, Python will see this as two different objects, two different code structures that it's going to do things with. So that's why I have an underscore in between the words, linking them together as a single structure in this code. There's many different words I could use for this, but this retains this thing's identity as a single variable and not two separate words. So input's going to take some information from the user and it's going to store it in this string just to see this running so that we can understand it. I'm going to say you typed in input string. So I'm using the stuff I did earlier with the concatenation of strings together to send some information out. And again, I've done the same thing with a variable, but this time the variable starts off empty until I take user input. So let's run this and I'll just show you how this works. So I've got all my previous print statements there, and I've got this interesting bit here where the program hasn't finished, but it's no longer running. It's paused right here. And it's paused here because I ran the input function, which is going to wait for me to type something in. So I'm going to say, hi, my name is Mark. And it's going to say, you typed in, hi, my name is Mark. And I'm just like, okay, cool. So now we have the ability to take information from the human when they're running the program. So as opposed to taking information from the human well in advance when we're writing the code, now it's whoever's sitting in front of the computer at the time it runs is going to help it to do things. So I can now put some input in. And that's okay, but in its current state it was actually a little confusing because the program just paused without telling me anything. It just paused in the middle of what it was running, and we're like, okay, maybe we need to give the user some prompt. Tell the user that something is actually happening, rather than implying that the program's just kind of stopped and there's actually no implication, and we're implying nothing. So it gets confusing as to what's happening. So let's try saying, please type in your name. So this is different from just having an empty space there. What we're going to get this time is this text will appear. So input is actually doing a print as well as an input all at once. So it's a nice function because it can do that. So please type in your name, and then that cursor will wait there for the name. And then what we might say is, hello, whatever the person's name is. So let's see if this works. I'm going to save this, run it, and now it says please type in your name, and the cursor appears. So now there's an actual prompt. So again, when we're looking at things from the user side like this is a nicer program. It understands what we might need. If it's going to pause in the middle of what it's doing, then we might need to know why. So it's asking us to type in our name. I type in Mark, and it says hello Mark. And so that's a lovely little thing where it is able to use the information that I have typed in. And there's going to be different ways that we can do that. However, I think that this video has probably gone long enough now. I think it's actually reasonably long. I will go on to other stuff later. But I will leave it here, having shown you some basics. So the things that we covered in this video are how we create and modify variables in Python, how we can print out variables, and how the type of the variable might make a difference to how the code uses that variable. So we saw the example, like if we have numbers on either side of a plus, it knows to do numerical arithmetic operations. If we have strings on either side of a plus, it knows it's going to concatenate them together. And if we had two different types on either side of this plus, it gets confused as to which of those things it wants to do. So what type our variables are changes the kind of category that the information is in, and that changes how that information can be used. We then went on to look at input, and we're going to look at this a little bit further as we go along. But I didn't want to pack in too much into this one video. This is like an introduction to what we're going to show later with input. So I can create an empty variable like this. This was an empty list that I created here. We'll look at lists later because they're like a really interesting programming construct that we're going to do more with. But this one's empty. And then I give it a value. I assign it a value using the input function. The input function said, I will tell the person this, and then they will type in something, and I will put it into this string for you. So we get the value in the string, and then we can use that variable afterwards to do other things. So this isn't the only time that we're going to be taking input from our user, but we will be doing that again in different ways, and that's where I'm going to go to in the next video. I should also say that as I wrap this up, I do have a Patreon, so if you're interested in getting this source code, I mean, obviously, if you want to, you can just write it down, but I'm going to save it in a text file, along with some instructions and some guides on the technicality of what I've done here. If you're interested in that, I'll leave a link to the Patreon below. I've got a few people in the Patreon already. Thank you very, very much for supporting me. I hope this kind of thing helps you. Or it helps other people that you want to show this to. That's also great. But I'll leave it there, and I'll say next time what we're going to do is we're going to go deeper into this input and numbers and the arithmetic, and we're going to build this up from just having seen the concept the first time into really using it to do something a little more practical than what we've got here. But until then, I've been Mark. Thank you for coming to the Mark Chi School for kids who can't code good and want to learn to do other things good too. And if you're interested, hop on the Patreon. I will send out this source code as well as some notes. And I will see you in the next one, and we would go deeper into both input and variables, and we start doing some actual D&D style calculation of things. All right, see you later.